All right, checking the operation of a Mamac power supply, take two, because I started recording this earlier, and when I went to check the milliamps across the circuit, I ended up trying to check the voltage and left the leads in the milliamp position, and kapow. So I done blew up my meter, so this is going to be, rather than trying to get this fuse that I blew, it's Sunday, nobody's open, so I'm not going to get one today. I figured I'll go to garbage freight, 20 bucks, pretty much the same price as the fuse, and now I get to also do a review on a meter. So I'm going to go ahead and get this open, get this fired up. And then we'll go through the transformers. What happened was I've been having problems. I work on building automation systems, and we've had a DP reading, a DP sensor for a building that was not giving a good reading, and it was low, and when we verified it, it wasn't low. The milliamp readings coming off, it was fluctuating and really on the low side. When you're using a DP sensor like this for building pressure, disconnect the tubes, and the sensor set up to read both a positive and negative number. It was reading about 4 to 5 milliamps rather than 12 milliamps. It should have been reading. After the guy had replaced the DP sensor but hadn't checked the voltage reading to positive and negative to see if he had 24 volts. Ultimately, after finding out that the new sensor didn't work, checked the voltage, and it was reading about 19 volts DC instead of 24. So this transformer is putting out about 19 volts. And if you can see, the capacitor is bulged at the top just a little bit. And I'm guessing the capacitor is gone. This thing's live, but if you look at this one, it's not bulging. This is a good one. So I'm just going to run through checking the two of them, comparing them. But the main thing I want to do is I want to pull into the building automation system the milliamp reading for the voltage output, right? So if it's outputting 24 volts DC and I put it through a set of resistors, 2000 ohm resistor, that should give me 12 milliamps, and I can feed that 12 milliamps back into the BMS panel, and that'll, I can put it into a table statement where it reads, at 12 milliamps, 24 volts DC, and then put it in a table statement. So the lower the voltage goes, the lower that milliamp reading, and then alarm it and be able to proactively catch a bad transformer. Right. So let me get this meter fired up, and we'll give it a test. All right, so I got the meter set up. Let's move this out of the way. So what I'm doing here is I'm going to measure the voltage DC coming out of this transformer. We've got bad connection. Look at that, the meter does read 24.06. So go ahead and adjust. Get on there. Right. Adjust it, try and get right at the 24 volts. cooperate. All right, 24.01. All right, that's as close as we're going to get. So if I switch this over to milliamps, as far as the meter, I don't have to switch the probe, so I can leave that probe there. Just switch it over to 60 milliamps. And if we go in, how I blew up the meter last time was I went straight across that. Oops. But here we're sending 24 volts into a set of resistors here, 2000 ohm resistor. So with 2000 ohms at 24 volts DC, and I read the milliamps back. I should have 12 milliamps. I got 11.98, 11.97, so we're right there. If that voltage were to drop, right, so let's do this. I want to be able to connect this and read it at the same time. Right. So if my old meter is good for reading voltage, so what we're going to do here is connect the old meter up. Volts DC. I should have 12 volts, 24 volts DC here. Let's see what I do here. Switch the probes here. This way I can connect crimper to this. All right, so get this right. All right. So if we connect this up here, we're going to get the 12 milliamps. Now if I read the voltage, let's say the voltage starts dropping, which I think is clockwise on this pot, right? So you can see the milliamps dropping. If I connect the meter up, I'm at 21 volts, right? So this power supply will go down as low as, I believe, 5 or 8, right? So as my voltage drops, my milliamps drops. The point where BMS system, if it's drops below 4 milliamps, it'll usually read a fault. That's right around 8 volts. Right? And this power supply will, well, go down below 5. It is adjustable. Right? So we'll get back up to the 24 volts DC. I want to show you the other power supply. All right. 12 milliamps, 24 volts, I'm going to switch out the power supplies. Then we're going to look at this guy. What was happening was I think it was reading about 19 volts, and we were about 4 milliamps. So let's just give that a test. All right, so I switched out the power supplies. Now, still got this guy set up for milliamps, reading off the resistors coming through. Let's just measure what we have for volts DC coming off this. And we're going to plug it in. All right. So volts DC. It's reading 19.3. I'm reading 9.69 milliamps. Nothing's changed with the resistors. Now what I noticed with this is the pot really wasn't adjusted. So if I bring this back up to 24, can I bring it up to 24 volts DC? And if I do, will I get the milliamp reading I'm looking for? And so it's maxing out, right? I can't tweak it any further. I've got 22 volts DC coming off of this. The power supply just won't put out the power I need to get that reading. So I can't go up any higher. All right, let's tweak it until it's adjusted. So I'm pretty sure that capacitor blew out. Now, what would happen is if this is connected to the building automation system and we're got a known value here, 2000 ohms, 24 volts DC, you should be getting the 12 milliamps. I would take this reading and set it up as an alarm, right? So anything below, well, let's say 11 or 11 and a half milliamps, it would give us an alarm into the system to tell us we have a bad power supply. Like I said, this was reading 19 when we found it. We had the same problem with another transformer, same exact model, on a rooftop unit, and the static pressures, I think that transformer was putting out 17 volts DC. The static pressure sensors on the air handler had basically weren't reading static, so they're feeding back like 4 milliamps. So the VFDs on the fans ramped up to full speed, so that air handler was maxed out for speed. Running at 60 hertz. I think it was a fan wall, so it might have been running at a higher hertz than that. And when we went up to that air handler, measured the static at the unit, we were measuring about 4 inches of static. Building was well over the 2 inches that the building was set for. So bad transformer can give you really bad erroneous readings into your BMS system and just drive equipment crazy. The other thing I kind of want to look over is these static pressure sensors, these Mamac sensors. Maybe I'll do a different video on these, but these guys, it was a slightly different one we were using for the building pressure. I think they got an R3 version that will read down to plus or minus 0.25 inches. This one will do plus or minus 3.75 inches. These we've been finding a lot on rooftop units that are measuring CFM across the fans. They're measuring the velocity pressure, which gives them essentially a CFM that the fan is outputting. And the calibration of these out of the factory have been horrible. So we had to go through and recalibrate them. And using a pump like this, right, I'm able to simulate. We were running the range of 7.5 inches, or 0 to 7.5 inches, and ramping, recalibrating these things. And brand new out of the box, we replaced a couple before trying to do the calibrations, and we found one that was spot on, dead on accurate. Running it with the pump through the full range, reading the milliamps, and then the other one out of the box was garbage. I didn't start to see a change in the milliamp reading until we got up to 2 inches. So you got to be careful of these guys. But I'll do another video on the full calibration on these things. As far as back at this transformer, I think I will pull this apart and check the cap. Maybe do that in another video. I'm not going to do that in this one, but it might just require a replacement of the capacitor. So I will give that a shot and see what happens. Thanks for watching.